So welcome back. This is part two of our naming video series. And so in this video, we're going to talk more about that naming, and we're going to look at actually writing these formulas. So going the opposite way. So originally we talked about ionic bonding. Now we're going to talk about covalent bonding. So a couple reminders: covalent bonding occurs between two nonmetals only. Okay, so they're happening those are on the right side. They're going to be close together on the periodic table, with the exception of hydrogen. Hydrogen's always weird. Remember, because it's a gas, it really follows the needing one electron, so it really should be in group 17. However, it has very similar properties to group 1, so it's special. But that's a nonmetal. The formula is going to help us name the compound. Okay, so it's very important that you have your formula correct, because that's going to name the compound. The formula will not reduce down. So here's the big thing with ionic compounds: you can reduce down. So if you have a subscript of 2 and a subscript of 4, those are both divisible by 2. You can reduce it down to 1 and 2. In covalent bonding, we don't want to do that because it changes the name. And we're going to see that in just a second. So we want to keep our subscripts as is because they're there for naming purposes. So first thing you need to know is prefixes. Covalent bonding, you need prefixes to determine how many atoms you have of that specific compound. So in ionic, the charges tell you how many you need. In covalent, the prefixes do. So your prefixes are: 1 is mono, so think of like going mono, e-mono, it's 1 on 1. Di is 2, okay? Like you have a dipole or you have a diatomic. Remember we talked about diatomic elements, those elements that can't be left alone, you need 2 of them. Tri is 3, like a tricycle. Tetra is 4. So if you ever played Tetris, if you ever noticed in the game Tetris, they all have 4 squares in each of the shapes. 5 is penta, like the pentagon. 6 is hexa, like a hexagon. 7 is hepta, like the heptathlon, you do 7 events. 8 is octa, which is like a octagon, okay, or a stop sign, 8 sides. 9 is nona, and then 10 is deca, like a decathon, okay, or a decathlon, I should say, where you have 10 events. So when you're naming your covalent molecules, you're going to do these steps. So 1, you're going to determine the first element and its prefix based on the subscript attached to the symbol. If there is no subscript, which means there's only one, so scientists are lazy, we don't like to write extra things, so if we write this symbol, it has one of those atoms. If we have multiple atoms, we're going to add a subscript to tell us how many there are, okay? So if it's 1, you're not going to attach the word mono to that element name, okay? So the first word will not have mono as a option, okay? It'll either say just the name or it'll have a prefix from 2 to 10, okay? Next, you're going to determine your second element and its prefix based on the subscript. So if you have a 7, you're going to use this prefix hepta. Okay, if the element's name starts with an O, you're going to drop the vowel at the end of the prefix. So for instance, mono and oxygen become monoxide. Okay, and then you're going to change the ending of the second element to "ide." So here's the big thing about naming. No matter if it's a covalent or an ionic bond, the second word always ends in "ide" if it is just 2 elements. We're going to talk tomorrow about what happens when there are multiple elements, so 3 or more. Okay, but right now, if you're just dealing with 2 elements, the second word is going to end in "ide," either way, covalent or ionic. So let's look at some examples. So I have N2O. So I'm going to determine my first element, or sorry, my first subscript, which is 2, and that is di. N is nitrogen, so di-nitrogen. Okay. Oxygen has 1, so that prefix is mono. Okay. Again, because the oxygen starts with an O, we don't want to do monoxide, so we're going to drop the O. Okay. And it becomes monoxide. Okay. Monoxide, so dihydrogen monoxide. All right, let's try another one. I have CCl4. So my first element is C, it's carbon, okay, but there's only one of them. I don't have a subscript here, Okay, you do not see a subscript here. Since I don't have a subscript, I'm just going to write the word carbon. Okay, next I have chlorine, which then becomes chloride. Remember, her second word always ends in "ide." And there's 4 of them. The prefix is tetra, and I attach chloride. So carbon tetrachloride. That's the name. So the prefix is really helping, or sorry, the subscripts are really helping us to determine our prefixes. So now that we have written our names, sometimes I'm going to give you a name and you have to tell me the formula. So the first thing you need to do in any situation where you're given a name is determine, is your name an ionic bond or is it a covalent bond? So remembering that ionic is the ones that are going to be a metal and a non-metal. So if your first word is a metal, you have an ionic bond. Okay? All right. If it is covalent, you're going to write the symbols, you're going to look at the prefixes, and you're going to write the prefix number as a subscript. If your formula is ionic, you're going to write the symbols just like before. However, this time, instead of writing your subscripts right away, you're going to figure out your charges. You need to figure out how many electrons are given off or taken on. Once you've determined your charges, you need to do an applesauce or a sandwich question. Again, do your charges have the same number? If they do, you're just going to sandwich your symbols together. If your numbers are different, okay, so if you have a 4 and a 2, those are different, you're going to crisscross applesauce. And then you're going to push your symbols together. So if your numbers are the same, you just push the symbols together. You don't need to put subscripts. If your numbers are different, you're going to crisscross applesauce, which means that number that's at the top as a charge is going to become the subscript on your opposite element. Okay, and that's back from when we looked at bonding. Okay, and then you're going to squash them together like a sandwich. Okay, so let's look at some examples. So my first one is magnesium sulfide. So my first question is this ionic or is this covalent? Well, let's look at my first word. It's magnesium. Magnesium is on the left side of the periodic table. It's in column 2. It is in row 3. Okay. It is a metal. So I have an ionic bond. So my first step is to write my symbols. So magnesium is Mg. Sulfide is sulfur, right? Remember, we're going to change that I back to what it originally was, which is sulfur. Okay. And then I'm going to figure out the charges. Well, luckily for me, magnesium has a fixed charge. It's not a transition metal. So it's in column 2. It has 2 electrons on its outer ring. It will give up 2 electrons. And because it gives up electrons, it lost some weight. It has a positive charge. Okay. Sulfur is going to take on 2 electrons. Because it has 6, it needs 2 more to get to 8. Remember, it's all about that magic number 8. It's going to take on 2. It's gained weight, so it's going to be 2 minus. So in this case, 2 and 2 is the same. So I'm just going to squash them together, and it's MgS. Making sure you're capitalizing where it's important. Okay? All right, let's look at the next one. All right, carbon tetrahydride. All right, carbon. Looking at this first word right here. Carbon is a nonmetal, and then hydride is hydrogen. So I have 2 nonmetals. So am I a covalent or ionic bond? I'm covalent. So I'm going to write my symbols. C for carbon, H for hydrogen. Okay. And then I'm going to look at my prefixes. Well, carbon doesn't have a prefix, so I'm going to leave it alone. It doesn't need a subscript. Hydrogen or hydride has tetra. Tetra equals what? Correct. 4. Tetra means 4. So I'm going to put a 4 as my subscript. And then I'm going to just squash those letters together. And it's CH4. Okay. All right, let's try a couple more. All right, I have pentaphosphorus decaoxide. Okay, so this seems like very big. All right. In this case, I'm going to do the same thing. I got to figure out first, do I have a covalent or ionic bond? So I'm going to look at my first word, pentaphosphorus. Phosphorus is my element, and it's a nonmetal. Oxide is my second element, okay? And that means oxygen. So it's two nonmetals. So I'm going to do a covalent bond. So I'm going to write those symbols. So phosphorus is P, oxygen is O. Oops. So I'm going to look at my prefix. Okay, my prefix next to penta is, sorry, my next to phosphorus is penta, and penta means 5. So I'm going to put down 5. And then oxygen is attached to deca, and deca means 10. So I'm going to put 10. And then I'm going to squash them together. Now, here's a very important note. Remember I said we do not want to reduce down? And that's very important because if I reduce down P5, O10, because they are reducible, both numbers are divisible by 5, I'm going to actually make a different molecule, okay? If I reduce this down, I made PO5. That's phosphorus pentaoxide. That is different than pentaphosphorus decaoxide. So it's very important not to reduce our covalent bonds. All right, let's look at another one. All right, oh, this one is a transition metal. How do I know? Well, it's very easy to see right away because I have a parenthesis. So that's going to be a really big clue that you're dealing with a transition metal, metal being the operative word. So I have a metal attached to oxygen, which is a nonmetal, and so that means it's an ionic bond. So I'm going to write down my my symbols. So I have lead. Okay. Now here's really important. The parentheses, the Roman numerals in parentheses, are going to tell you your charge. So lead 4 means I have a 4 positive charge. How do I know it's positive? Well, metals will always be positive. They're going to give up electrons. They're just good like that. Okay. So then I have oxygen. And oxygen has 6 electrons. It needs 2 more to get to that magic number 8. So I'm going to do a 2 minus. In this case, these are opposite numbers. They're not the same. Okay, 4 and 2 are not the same number. So I'm going to crisscross applesauce, which means this 4 right here is going to attach to the O, and this 2 is going to attach to PB. Now, in ionic bonding, I can reduce down. Okay, so 2 and 4 are both divisible by 2, and so I'm going to reduce them down, and my new product is PbO2. Now, if I was writing this in a chemical reaction, I would put a giant number 2 out front to say that really I have 2 PBs and 4 oxygens, but we'll talk about that when we get to chemical reactions, okay? So that's all I have for naming and writing formulas right now. Come back on our next lesson and we will talk about what happens when we add a couple more atoms to this and we make some fun things like acids and polyatomic ions. All right, get to work on your activities.